One. Good afternoon. Thanks for joining in, and want to just take a moment to introduce the presenter today for Power Factor Correction. His name is Mike Papini, and Mike is owner and CEO of Global Energy Solutions Group out of Indianapolis, Indiana. And he is an inventor and a patent holder of the technology that does power factor correction. And there's a number of other things that it could do for introductions, but really for that, I'm going to turn it over to Mike to give the introduction and his qualifications.
Thanks, Dave. Yeah, my name is Michael Papini. I'm an electrical engineer. I have several patents in power factor correction. We're based out of Indianapolis. And you know, this meeting today is a Q&A on power factor correction to try to educate the public on what we do as far as saving energy.
All right. Well, and Mike, people that will see this are going to range anywhere from top-end engineers at the moment that you mentioned power factor correction, they're going to know what we're talking about, or I'm sorry, what you're talking about, all the way down to possibly a corporate controller or CFO or just an accounts payable person that power factor correction, or I'm sorry, power factor number on a billing statement is just a line item. They don't know what it is and don't know how to reference that. It's just an amount due that they pay, aggregated together with everything else. So if you could just explain what exactly the power factor is and how that affects a company's operations.
Sure. The power factor is the direct ratio between kVA current and kW. So kW is the working power that the motor is rated for the horsepower. And then the kVA current is the magnetizing current that makes the magnetizing field for that motor to run in. So what happens is that the amperage on both kW and kVA together make the apparent power so that the motor needs to run in. So what that is, for instance, if you had a motor that was running at 100 amps and the power factor, for easy math for this, would be 50, that would mean 50 of those amps are kW, 50 are kVA. So when we go out with the patented process, and we can take that power factor from that 0.5 up to 0.99, which then would reduce the amps to 50 on the power company side, and in front of that, or in back of that capacitor, the amps will drop by 50 because the power factor is raised to 0.99. So the motor is still getting the amount of amps it needs, both the 100 amps that it takes to run it, but on the back side of that capacitor, it drops it down to about 50 amps on that. So by doing that, it cools the wire down that if the delivery comes in, which is called I²R loss. So that's heat on the system, which is kW. And then intrinsically in that motor, it corrects that motor internally, which then drops it on average about 10 degrees centigrade. So that's also heat that you're paying for that's really doing damage to your motor. So there's many places you can research that. The intrinsics on the motor, if you save 10 degrees centigrade, it'll actually increase the motor life by 50%. So there's a lot of benefits to looking into power factor, not just the reduction in the bill, but also the conductors, the life of insulation on your conductors, that's all extrinsic losses. The intrinsics of the motor is that the motor cools down, friction windings less, core losses, eddy losses, all those different types of losses in the motor are corrected. And that's, your bill goes down, but then you also have longer life to your motors.
Now, with that, that is an explanation of how it affects the systems, at least from the operational standpoint. But how does a low power factor specifically affect the electrical systems and energy consumption? Because we talk about this in a lot of clients that look at this is something that could be beneficial for an organization, a facility, whether it be commercial, industrial, if they have fans, HVA systems, just places with a lot of moving parts. How does a power factor that is out of unity, I guess you'd call it, affect those systems?
Yeah, it puts a drain on the system itself. So if you have the capacity of your conductors, like using that example I used earlier on dropping 50 amps, it actually makes the current flow or the voltage flow, gets better. It actually increases the voltage. So that in turn, inside that motor, gets rid of a lot of that wasted energy that's in there. You also have a complication with using LEDs or VFDs that put other frequencies on the line. It's harmonics. And that is something in today's world that we really have to deal with. What that does is it distorts the sine wave. If your system is running at 60 hertz and you have a fifth harmonic on that line, that's 300 hertz. So the harmonics have no place to go. So what they do is they find low impedance that's on the system, which would be a motor windings or transformer windings, things like that. And it creates a lot of heat on the system. And it really distorts the sine wave really bad. So by getting rid of that, that's part of when we correct the power factor, we also look at the harmonics in that building. So we deal with it right at the load or right where the K-bar is being consumed. So we correct any harmonic issues right there using filters or tuned reactors.
All right. In a lot of the buildings that are built today, in some of the organizations that we've talked to and that we've come across, they have developed the ability to be energy efficient. They have these systems in place. They have LED lights. They have energy efficient air conditioners and energy efficient everything. But yet there have been a handful that when we've looked at them, even though they're energy efficient, everything has been built. It's insulated. Everything you can think of, their power factor still low. Why would that be?
Well, by design, the motor itself is inefficient because you need kW and kVA. So what happens is you might need a motor. I'll use a sawmill for an example. So you have the head saw that usually is about 100 horsepower motor on there. So what happens when it's under load, it's using that 100 horsepower, right? So when the log goes through and then the motor's just freewheeling, it's only about 25 horsepower. So what happens there is the power factor goes from say 0.8 down to 0.4 because now the magnetic field is really big in that motor because we're not using the horsepower that it's designed for. So even if you have that 100 horse, or the wattage of it, it's only at 80%. You always have to have about 20% for the kVA for that magnetic field for that motor to run in. So just by design, that's what happens. So as we correct the power factor at each load in the building, inductive load, as we correct it, we build the power factor up at the meter. So it's corrected all the way back to the power company.
In your estimation, what power factor rating should an organization be operating at? Because it goes from anywhere from 0 to 1.0.
Yeah,
1.0, I'm assuming, would be very difficult to achieve. What is, in your estimation, where should everybody be aiming towards?
0.95 or above, because power companies' penalties vary. So it depends on the tariff with the power company. So you might have one company that doesn't give you any penalties at 0.9 or above, like Duke Energy over in Ohio is that way. I have companies over here that's 0.95. You get penalized all the way, until you achieve above 0.95. For me, for my products, I can achieve that 0.99 on the individual loads. So it's not impossible to achieve it, or one I could even get, but I leave it at 0.95 because I have variations in voltages. So, you have to kind of watch that. So, but bringing it above 0.95 is perfect.
Where do you find that most companies reside at? It'll say light manufacturing.
Yeah, most of them, I'll read you one here. I'm sorry, I thought I had it right here, but, so power factor in most companies, I'm sorry, I got it here. Sorry about that.
That's all right.
But I want to be exact, so, they range anywhere between, 0.6 for like sawmills, things like that, or 0.6 power factor. And then, hospitals, granaries, things like that, they run about 0.75. National averages are, you can actually look it up online or whatever, but most of the stuff, you can look up and get. I don't know what I did with it. I'm sorry. I might have left it yesterday. But, so we're able to, look industry-wide. I believe I don't have that. Do you have that? So, what we have is the sawmills average power factor is 0.45 to 0.6. The plastics, extruders, things like that are 0.55 to 7. Machine tool shops, stamping companies, things on that are 0.6 to 0.7. Plastic textiles, chemicals, and breweries, 0.65 to 0.75. Hospitals, granaries, foundries, between 7 and 8.
Now, when you look at one of those companies, I'm just going to take, for example, you said the 0.6, and your goal is to get them up to 0.95. What does that process look like?
So what we do is we go in, we have a sizer, we hook up the sizer to the load, and then we switch the switches on and off until we can get to that 0.99 or unity. Once I get to that, then we build a specific box for that motor. So that's for an individual motor. It's called a static box. I also have automatic boxes to where if we had, like I do a lot of stuff with Amazon, if their pickers and things like that are multiple motors, they might have 50 motors on those belts throughout there. So there, instead of putting 50 boxes on there, we would put one on the MCC or the motor control panel, and then or cabinet. And then that would be an automatic, and that would take, it has different channels. So as motors turn on and turn off, it keeps the power factor at a 0.99. The other one I have is a hybrid between a static and an automatic, to where that measures current. So what you don't want to have is to have boxes on all the time if the motor's off, because now you're putting reactive power back into your electrical system. You could be, harmonics, you could have a lot of distortion on there. It does a lot of, resonates voltage, does a lot of different things. So the hybrid box I have has a CT, and as soon as the motor turns on, it turns the box on. When the motor shuts off, box shuts off. So it's 3 types that we use to achieve what we're doing. So it's kind of takes about a day to go through a factory and do everything. It doesn't take long to do the sizing, but it's pretty accurate. It'll let you know exactly where your equipment is and everything. Then we bring that information back to the office, goes into our software that we have specifically designed for us, and that'll give you the breakdown of how much savings in KW, what your ROI is going to be, what your carbon credits will be, all that type of stuff.
Now, that's based on savings as of the day that you do that, because the rumor, if you go out and do a search online, there are, now, at least in Ohio, and I assume it's across the country, that energy rates are set to go up pretty significantly here in the next 6 days. July 1st, I believe, is the date I heard or read. You're not seeing a lot of news press about that, but if you do a search, it does come up. And I had someone tell me that the companies and individuals really don't have any idea what's about ready to hit in July. because there's an auction, I believe, the energy auction back in September of 22, and
Yes.
one in February this year. Uh, they're pretty significant increases. So
Yeah, here in Indiana, we're showing between 3 and 4 cents per kW. So it went from like 9 cents to 13, 14 cents a kW.
which is actually pretty significant. That's
Yeah, it's almost double.
easily 25 to 30% increase.
Yeah,
So now, and obviously, if someone does a power factor correction based on today's pricing, when the new rates come into effect, the ROI to come back on that's going to be significantly shorter because essentially you're just keeping your rates of what they were,
yeah.
hopefully a year or two previous.
Yeah, the when I do the sizing, it's that specific day. I can guarantee the savings on that day. So, you know, to quantify it the next month on that savings, there could be variations there where they might have had a shift change, or say in a machine shop, they might have not been real busy this week, but the next week they got a huge order, so their bill's going to go up and down. But it's still relevant. It's still the same savings all the way through. So if it's 20% at 10 cents a kW, it's 20% at 14 cents a kW. So it's all relevant in that pricing. The accuracy on my end is if I get the right information, if it's running 8 hours a day, you know, 30 days a month, I can do that very easily. But if it's running 4 hours a day and the guy tells me it's running 8, I have no way of knowing.
Right.
You know, I have to go by what I'm told. And that's where it has to be pretty exact on those savings.
So when you go through, you do the initial analysis and you go and you do your sizing and plug it into your software, and kind of it puts how you need to develop each box, which I assume everything's custom made for the location it's going to, and you get it built and you install it. So does this go up to what you call Unity or 0.99 when you flip the box on, or is it a process?
When you flip the box on, it's
Oh, so it's instantaneous.
Yes.
Okay. So theoretically, you don't have to wait to see. You don't have to wait 90 days to begin to see it. It starts the day.
That's correct. And then you can actually, I do a lot of data logging like that. So I would put a box on what it is, motor or wherever, and then I go back to the gear or back to the bucket where the breaker is for that motor, and that's where I put the data logger on that to data log, because I have to take in all the I squared R loss heat, all the intrinsic heats, all that stuff has to be done back at that breaker. If I do it right at the disconnect, it won't give me all the heat savings in that. So I'm usually pretty accurate in it. Always about 3 to 5% plus or minus on the savings and ROI. You know, it just depends on, you know, what it is. So
Do you have an image of the box of what it looks like that you could put up on your screen?
I can, you know, let me show you, take this right here. So this is the sizing. It's going to take me a second to get a box up there, but this is how we do the sizing itself.
Yeah, take us through the process.
Okay, so can you see oh, hold on. I don't see the thing around it though. Can you see that?
You can see it. Your sizer right there in the middle of the image.
Yeah. So what that is oh, I'm sorry.
Hit play?
Yeah, hit play. So it's going to be kind of loud.
The volume isn't coming through, not at least on my end.
So that's what we're doing now is I'm switching those switches on and off. I'm bringing that power factor to a 0.99 from a 0.58. And this will give you the instantaneous. So as I switch, you can see the power factor building up. It's 0.82 now. And now it should be 0.99. So when I go back to the amps drop down to 19 from 32.
And then is that a what kind of facility is that at?
So I can hardly hear you, Dave. Let me just go through it again. So we're at
Okay,
18.
sure.
So now the motor itself is still at that 32 amps. So it's from the power company. So where it's installed, where I have those wires up at the top here, we're going to be back down to that 17, 18. Okay, shut that off. So that's the sizer there that we use. That's what I have the patent on. But you can kind of see how at each one of those motors, that took me, what, less than 2 minutes to do that. So switch 7, I know how much microfarad is on that row of caps in that sizer, and it'll tell me what size box to build for that. And then you do that throughout. That happened to be at a gravel bank we did. So there's multiple motors throughout that bank. I was out of there in 3 hours after doing that whole sizing for that. And I think they were at 22% savings on their bill, and the bill was, I think, 80,000 a month on there. So significant savings on there, plus motor life and all that. And they run year round at that particular one.
And I'm sorry, you might have mentioned this and I missed it. What type of facility was that?
It was a gravel bank where they bring in gravel
Okay.
and they grind it up. I mean,
Okay.
yeah, big rocks down to everything.
Okay. Because we were
Aggregate.
using about a year ago, it was an indoor water park, and they have several different meters that we were measuring out, and we're all thinking that, well, where the water park is, that's going to be the worst power factor because of how much power they're probably pulling to run the pumps. To our surprise, that location was actually the best rated, probably because the pumps aren't fluctuating; they're just running this consistent beat the whole time. What was actually the worst power factor number part of the facility was their banquet facility.
The
And
banquet.
yeah, which I guess because it's got more moving parts, it has a lot of fans, a lot of air conditioning, a lot of just
Yeah.
things going in and out that aren't running consistently. And so that was kind of an interesting discovery to that, because what we would be thinking that would be horribly inefficient really wasn't, and what we thought would be
Good.
fairly wasn't.
It's the opposite. Yeah,
Yeah.
usually those motors are on VFDs in there, so they become real efficient, like
Mhm.
above 0.9, because they dial down the hertz on a VFD, so variable frequency drive. So what that does is it keeps the water pressure at certain levels, so you're not running the water pressure at full all the time. So it's
Okay.
kind of like a dimmer switch. But what creates problems with VFDs, LEDs, servo motors, things like that, is they're called nonlinear loads. So the nonlinears are all electronics. So they create harmonics on the system, the 3rd to the 13th harmonic. So the damaging harmonics are the 5th, 7th, 11th, which are VFD, servos, and the LED. So with that, my boxes, when I make them, it's the way I also have a patent on the way I wired the boxes. So I use kind of, for lack of a better term, it's kind of like an active filter, where it'll filter out 90% of the harmonic or the THD in whatever that's hooked to. So it drops a lot of heat off of the system.
Mike, do you have a particular project that you've done recently that is just a really good case study to just pass on to what has gone from maybe not necessarily one of the worst power factors and raise it up, but just a good case study of where the client was able to really see significant
Yeah, I have a lot. I'll show you one. I want to go to let's go to, I'll show you what I mean on the harmonics too. So that's
and for
it.
those who may not know
This
what
one.
harmonics is, can you just give a brief description of what harmonics means?
Yeah, a harmonic is a different frequency that's on your electrical system. Right now, you're at 60 hertz. So, like a 5th harmonic, it's very easy to tell what the harmonics are. If you take a 5th harmonic and times it times 60 hertz, it's 300 hertz. So that wavelength is traveling back and forth on that same piece of wire that's at 60 hertz, which means it goes plus and minus 60 times a second. At 300 hertz, it goes plus and minus 300 times a second. So what it does is it distorts that sine wave, the voltage part of it. It kind of pyramids it out instead of being round. So your voltage goes down in those cases. It's called transients on the system. So the transient voltages then have no place to go, because every system, every appliance is 60 hertz, except Saudi Arabia and places like that are 50. But so here, that 300 hertz has no place to go. So what happens, it gets into the windings of a motor or the windings of a transformer. Through induction, it dissipates as heat. So it gets out of the system that way. That's why you have transformers that are real hot, motors that are hot, all that, because of the harmonic distortion. So we filter that out through a process. I use different methods of doing that, but that's part of the sizing on that. And then I'll show you this here. This is a car company here in Indiana. I don't think that's, you got that on?
Yeah, it's up.
It's up.
It is.
So point your pointer at the KW right there. So that KW is what it was before we hooked our box up. So it's almost 101,000 KW, right? So go to the after one. Yeah. You zoom in there. Yeah. And you can see after we put our box on, it dropped down. So that's 9,000. Well, 10,000, almost 10,000 kW savings on that.
Yeah.
So when you think about that, the heat on that system, on that motor and everything, I'll use the example that the guy from Duke Energy was telling me. It's like having 9 hair dryers going in a box. That's the kind of heat that we're saving off of the motor and off of that system. So now also, Joe, I need you to go to before this one. So here's the harmonics on that same motor. You can see that it's like totally out of whack there. So after we put our box on, now that creates a lot of heat on there. So after we put our box on, go here, you can see that, and this is all on the same motor. We just data logged it, and there's the reduction in the harmonic heat on there. So now we're back in the green on everything. The motor's happy, saving 10 kW. And that's just on one motor. This particular, that's on 125 ton chiller. So they had 5 of these chillers on the roof of that building. Plus they had another, I think 50 or 60, might even be close to 100 RTUs on this, on that roof. So by doing all those, you know, you save a tremendous amount. I don't have the exact number on that, but I can get it. I don't have it with me. I don't want to misquote it, but I'm thinking it's about 20%. And their bill, I think, was about 250,000 a month, and they're saving 20%. So it's like 40 grand. Well, just that one particular one, when I did the sizing and put it in our back office, it was showing $350 a month savings. So when they did this test, I didn't do this. They rented their own logger and all that. But when they did that test, they calculated out the savings to be over 500 a month. So I was a little bit low, and I thought it was good savings at 300. But yeah, they calculated that out. I'm good there. You can take it off. And then I'll show you one more in Ohio, which over by you guys. It's between Dayton and Cincinnati. It's Heidelberg. It's this one here.
Heidelberg Distributing.
Yeah, that one. Yeah.
I gotta share this.
Okay. Can you see that one okay?
Yes, it just popped up. And that's a large warehouse facility that sits off of I-75 just south of Dayton.
That's correct. It's to the right there as you're going south. So on 75. So what that is, that's the utility bill from there. Of course, it had the logo up there as the Ohio guys, but so this was from June of 2017 to June of 2018. So it's just those months. It's not the whole year, right? So it's just what it was back in June of 17 and what it is now of June of 18. So the way that, if you look across there, you'll see the number there is 362. That's a degree day. Okay, so then of 17. In 18, it was 474. That means it was a lot hotter. So if we didn't have our boxes on, here you'll see that little red box there. That KW was figured out to be 725,470 KW, where realistically after our boxes, they only used 586,000. So the variance there is 138,000, or 23%, almost 24% more efficient with our boxes on there than without. And they saved about 7,000 a month on that. Are you still there?
Yeah, I'm still there. I was just jotting a note down. All right. Now, and Mike, we talked about this a little earlier, because you do have a presence in Saudi Arabia, and I believe you said you actually have a factory over there as well. Now, you have a significant presence there, and this seems to be power factor correction is not a new concept. If you were searching online, they were actually doing it back in the 80s and possibly earlier than that. It seems to be a lot more common overseas in the Middle East and Europe. Why do you think that it's more common there than it is here?
Well, it's just the way they produce power. So Saudi Arabia they use #2 crude oil. So it's all their power is fossil fuel generated. Where here in the US, our fossil fuel mostly is just in the middle or the Midwest. Everything else is nuke or water, hydropower. So we have 3 different types of power here that will do that. But overseas, and most countries overseas are still that fossil fuel generation. So they're getting fines and penalties by polluting the air. So they want to get off of those markets, and try to reduce all that. It's the same thing here. The problem is, and I've been doing this for 40 years. So the main thing, as far as for me doing it, I've been doing this, like I said, 40 years, but when the cost of KW was 3 cents, nobody cared. They were like, yeah, all right, big deal, so you can save some. But now that it's 14 cents, now it's a big deal here. Now they want to reduce their stuff. They want to reduce their carbon emissions. All that stuff is coming into play. I do boxes specifically made for car charging ports and stuff like that, because they're really bad. They're like 0.4, the power factor on those, because it's inductive. So it goes from 480 volts down to 12 volts, or actually probably 16. But by doing that, those are a big deal now. I've hooked up boxes at people's homes that have Teslas, and their bill significantly went down $60 to $80 a month just by putting on a box on it. So the problem with the electrical part of that, the charging of it, is we're fossil fuel generated here, or coal here in the Midwest mostly. So what happens there is every KW produced by the power company is 2.2 pounds of carbon in the atmosphere.
Wow.
So, and then it goes on national average, because of the nuke and all that, what's it, 1.3 or something like that pounds. But it still produces a lot, where you have petroleum is like 2.6. So I'm not seeing where the big
Right.
environmental impact is, because now you got batteries you got to throw away. I mean, it's, to me, but I'm in that field, so for me, I see it for really what it is. They're not snowballing me on it. So general public, they think, okay, it's power. No, who knows?
Mhm.
They're thinking solar panels and all kinds of stuff. But anyway, that's where I think power factor is more. Well, first off, it's cheaper and it's immediate, so you don't have to wait for anything. So as you saw when I did that sizing, you can
Yeah,
see where that was immediate
it went
savings.
right away.
Yeah. So yeah.
So currently here in the States, are there, that you're aware of anyway, are there any specific industry standards or regulations related to power factor correction? Is the government mandating anything right now? I assume overseas, some places they do.
Right.
And is some of that happening here in the United States, or do you see it that becoming something that'll be common?
Well, what they're doing right now, you're being penalized for sure. So if most of the power companies and their tariffs, the baseline number for them is a 0.85. So if you go below 0.85, you get hammered with penalties. And they're mostly, you don't really see it printed on the bill. It comes out to like demand charges. So they have different rates of demand. And then with the increment meters they have now, the smart meters, they'll take a picture of your electric system every 15 minutes. So whatever that is, whatever your peak is in that 15-minute period is where it's set. It doesn't go back down. So they charge you throughout the whole year for that one time that you turn all your power on at the same time.
Yeah.
So the inrush on that.
Now,
Okay.
Mike, to interrupt for a second, that's where anyone who comes across this and views this information, where if they work in anything financial, if they work in the finance department, the CFO, a controller, or accounts payable person, they won't know these things because things come across.
Right.
It just becomes it's an amount due down at the bottom. It's not. Some places it's line itemed, but they don't know if a power factor number, which sometimes is printed on the bill, sometimes it's not.
Correct.
It kind of depends on the utility company. They don't know that if their number is below a certain amount, that they, in your words, are getting hammered for it. And we've seen some of that where there are some places that it lines out on the bill your power factor penalty. But then again, if you're just working in the finance department, you're just seeing an amount due.
Bill. Yeah.
You don't really realize that you can address some of that.
That's
Is that
correct.
now,
Yeah.
is that something that that at least in the U.S. that we're going to be mandating certain things to attain a certain level? Do you see that coming?
Well, actually, the Department of Energy has put out studies on power factor correction to where, I think I have one here. Where they're telling you, actually Detroit Power put out a bunch of stuff too on power factor. So it shows in their thing, and I can send an email. I don't have it on my screen, but I do have it here that it says the why improve your power factor, and this is definitely from the Department of Energy. So it says the first thing, why improve your utility bill will be smaller, is what they're saying. It said low power factor requires an increase of electric utilities generation and transmission capacity to handle the reactive power component caused by inductive loads. Utilities usually charge a penalty fee to customers less than 0.95 to avoid additional fees by increasing your power factor. So by increasing that to that 0.95, or in Ohio, it's 0.9, or Duke Power over there. So if you can improve that, you erase a lot of the penalties. So my method of doing it at the load, I'm the only one that does that, or my company, or people that are dealers for me throughout the country. I have that patented method to do that. Most everybody else, the bigger companies put what they call autovar capacitors on the gear itself.
Mm-hmm.
So on your service entry. So what happens there is you're not correcting anything inside the factory. Everything remains the same. So your motors are still creating the heat, the power factor is still 0.6 or whatever on the inside of the building. On the outside, on the power company side, they love it because you know, it's corrected to
Yeah.
0.99. So they reduce the penalties, but there's no I squared R loss, so there's no extrinsic or intrinsic losses in the building. Plus, your motors are all still inefficient inside the building. Plus, now with nonlinear loads, the capacitor banks are low impedance. So now instead of all that harmonic distortion or THD in the building, it actually will go to that capacitor bank because it's low impedance, and it usually boils the dielectric and then blows up the cap. And so you spent 90,000 on a capacitor bank and it's wrecked within a short period of time. So there's different ways you have to put that equipment in, and then you have to use tuned reactors and all that stuff to combat the nonlinear loads.
Yeah, because I've seen a number of different things, at least from a government regulation, government studies that that I've searched over the past year or so. That energy.gov has, if you search power factor correction energy.gov, there's actually studies that they've done dating back to 1987 that they posted online. So this is not something that's new. And
Oh no, yeah.
it doesn't matter necessarily which party is in office. They're all driving towards the same goal. It's just that we haven't really heard a lot about it until here recently, in the whole push of sustainability and becoming energy efficient. And you know, with the energy rates going up, I don't know about you, but I can probably count on close to two hands how many um, electric generating facilities that have been decommissioned in the last couple of years. They
Right.
keep decommissioning facilities. I don't hear any news about the new ones opening. The at least from the governmental level, they're talking about installing a bunch of charging stations for electric cars throughout the United States.
Absolutely.
They're not building new electric generating facilities, so this is just going to keep burdening what we already have as it become less and less and less each year as we go on. And energy rates I don't see coming down anytime soon. As a matter of fact, I see it going the other direction. And so this conversation that is, I think, is going to continue developing as time goes on.
You're exactly right, because what they're trying to do is close down these plants, these power stations, and replace them with solar. Problem is, with solar, you're 6-8 hours a day. You're not 24 like a big facility would be. So wind, you know, that's hit and miss. All the renewables that they have are just, I don't think are there yet. You know, I think there's a lot of research and development going on to do a lot of those things. The closing the plants, I just don't agree with. I think, you know, I'm an environmentalist myself, and you know, I don't believe in polluting the planet, but there's better ways to go about things where you don't have to do the extremes of that. So that's kind of where I'm at. And then the power company is going to capitalize on that. For instance, out in California, I had a guy out there that called me up and was asking me about the house box, if that would help with solar. And I said, well, no, it doesn't really help with solar because solar is KW. There's no KVA there. So you can't take a motor and plug it into a solar panel. It won't run because it's straight KW. But you can plug a light bulb in, it would come on. But so without that KVA current, you know, and that's where you come up with batteries, or you go into the grid, you hook into the grid and get your KVA from the power company. So you're never really off the grid. So when I was talking to the guy, I said, I don't think, he goes, well, send me one. I'm going to hook it up and see what happens. So he ended up hooking it up, and I heard from him about 2 months later. And he said, well, you know, I was getting a bill between $100 and $200 a month from the power company. He says, now, after I hooked your box up, I'm getting $50 to $100 a month in credit, selling it back to the power company. I thought, I said, I don't know how that's doing that. So I told him, I said, well, listen, send me, well, actually I told him, I said, well, maybe you were on vacation, you weren't using your house, something's different. So I said, just monitor for the next couple of months and then send me the bills before and after. So before you put the solar array in and after. So he was saving right along. And so when I was looking at the bills, I noticed that the demand charge for KVA was like $1.05 before he put the solar panels in. After he put the solar panels in, it went up to like $38 because they have to supply it. So they're losing money on the KW, but now they're making their money back on the KVA. So it's kind of they'll never tell you that, the power company, you know, they're just, that's the way they are. So I would, you know, I can see that stuff on bills. I think people should educate themselves on the power and how it works and how they're being billed. There's a lot of companies out there that would certainly educate them with that. You know, that's kind of what I try to do when I go in, when you were mentioning the CFOs and stuff like that, because I ended up dealing with a lot of those, not only the maintenance guys or the electricians there, but also those guys, because they pay the bill. So I kind of educate on how we do it, and ours is unique, doing it at the load with the sizer. So other companies are just putting in on the gear, and you know, they're not really saving that kind of money. So the CFOs are very interested in what we're doing and how we're doing it. You know, it's just an educational thing where, you know, they don't have to even know anything about electricity. You know, I'm very good at, you know, talking to engineers at this level and people at this level, and you know, just who my audience is at the time. So, but
and so Mike, facilities and organizations, manufacturers, whoever, I think at all levels, this is at least something that would be a very good exercise for an organization to do, to test just how efficient they're being, number one, and number two, are there places they can save money? Obviously, if they have a 0.6 power factor and they can go all the way up to 0.99, and that's an extreme case, but they could be operating significantly inefficiently and not know it.
right.
If there's an organization in the process that Energy Efficiency Group has, is it's a complementary process to go through and do the audit. What is the action steps? How is this, if someone comes across this and they say that this is something we should probably check into just to see where we're at? What's the process? How do they flow through that?
What I would do in that case is say, listen, let's pick out a motor in your facility, just one, like a chiller or something, 30 volts, whatever type of facility you have. Most every place has an air conditioner, so, or RTU. So I would go in there and size that one unit, put a box on it, and let them measure the savings through a data logger. And then they would instantly see that. Or I would bring my own data logger, hook it up. I could even do it with the sizer, hook it up, and then turn the sizer on, turn it off, and you can see the difference right away. So in that case, and then you'd say, okay, now multiply that times the 30 units you have on the roof and your other motors in your facility, and normally they bite on that and, you know, go with that.
So someone with they call up on the phone or they email and say, "Hey, we'd like to go through this process." I guess that the first is, and correct me if I'm wrong, that the first would be to compare a couple months worth of electric bills, just to see. Well, because some of the utilities do print the. I've come across Duke Energy statements that some have power factor number right on it in bold letters. And I've come across some that it's not even on there.
It's in demand is what they do. They change it around. But in those cases, the bill is kind of funny because power factor on a bill is the whole building. So power factor is an average of all the power factors in that facility. So you might have some at 0.6 and some of them are at 0.9, some of them are at 1. So if you have 10 things across there, and your low is 0.6 and your high is 1, and there's all different sizes in between, it'll average out. So it'll be like 0.79 on the bill, but you still have 0.6 in the building, you know, at that thing. So at the meter, it's an average out. That's why some bills, when you get it's like 0.85 or 0.9, and you're like, wow, that's pretty good. So but what happens in those cases is we would find the low power factors in the building, correct that, which would save on the KW usage. So you would save on that.
So on any particular meter, there could be several, theoretically, several motors or several different plot points that one of these units could correct.
That's correct. We went into Hitachi here in Greenfield, Indiana. Went in and was talking to the guys. I think one of the CFO, I think, was involved in that too. But we went back to their switch gear, and they were at 0.97 at the gear. And the guy goes, "Well, we don't need it. You know, we're above any penalties at 0.95 or at 0.97." So I said, "Well, let me show you something." I said, "Well, let's see, this thing here is hooked to." I go, "Where's this go?" So he says, "It goes downstairs on an air compressor." So I said, "Well, let's go down there and look at the air compressor." That was 0.7, the air compressor. So he was like, "How can that be if it's 0.97 at the gear?" I said, "It's because where it's installed back to the source, it changes, the dynamics change. In front of it, everything still needs that kVA. So now if I they were having problems with the capacitor bank that kept shorting out because of the harmonics in that building. They got a lot of robots and stuff in there. So we went in and did the facility all at the load correction, pretty much did away with that capacitor bank that they have there. And they're fine. As a matter of fact, they just called, they added some other stuff, and they want us to come out and put a couple more boxes in on the new stuff. So it's, you know, it works. I mean, it's different than, you know, a lot of people, because they get online and they see these hokey guys get on there and they're claiming there's one out. It's been, believe it or not, it's been out for, I don't know, probably 20 years. The guy said, "Oh, you plug it in the wall, saves half your electric bill, and the power company hates this guy." Well, it's the same device, and every year they change the name of it. So they just sell the crap out of it, and then it doesn't work. It can't work. There's no possible way it works. And then all of a sudden, I actually bought them. I have one in the back here that I bench checked. It's got a 0.04 capacitor in there. So you're at, I don't even know, probably a tenth of an amp or something you're saving. How does that calculate, you know, in a residential to half of your bill, you know? So people get fooled by that stuff. They buy it, they get mad, and then they go out of business, and then they just start up another one. So that kind of stuff is bad for power factor correction for the guys that, like myself and my dealers and stuff, that actually want to help people and product works, you know. But I got to defend it all the time because of that. I mean, you can see on those sheets that I showed you earlier, you know, I dropped 9 kW off of one unit, you know, out of the 15 they had there, or whatever it was. So I mean, that's true savings. When you can data log that, you know, there's no denying that.
Well, it's one of those, you have nothing to lose, but everything to gain.
Yeah, yeah, exactly.
And you bring up a point there, because there has been some pushback in some of the conversations and with the organizations we've talked to, where someone else, either they have a pre-established relationship with, get a second opinion, that say, you know, those things don't work. They question the effectiveness of it, and a lot of that is probably due to those people, like you mentioned, that try to game the system, because energy efficiency and sustainability is a buzzword right now, and organizations at all levels try to attain that, either by installing LED or energy efficient operations.
Sure.
And that doesn't necessarily equate to a high power factor. Those things may be energy efficient on their own, but when you get a conglomerate of pieces together, it even individually they're energy efficient, together they're not.
Correct. Yeah, it's tough to be in this right now because of all the fraud that's going on, and you know, people that are not you know, they're, I don't know, I want to say like electrician or somebody that doesn't really do this all the time but knows enough about electricity to say something about, and then right away the engineer from the power company goes, "Well, here's the power triangle, this is how it works, and you're not saving anything because we're not charging it for kVA." But the problem is, when I was at that meeting yesterday, I had to tell the guy a number of times that the power triangle is fine, but you're not taking into account the watts that are created by heat. You're looking at watts per horsepower, not watts by heat. And he's like, yeah, okay, I see what you mean. So then he drew the power triangle, and I said, see this little piece on the bottom, this little 20% of that bottom line, that's my savings. That's what I can save on there. So that total amount of kW for the horsepower of the motor is fine. That works fine. I can't even argue with that power triangle. But part of that power triangle is the watts that are created by heat. And that's what I can correct. And that's where the savings is. Finally, the light bulbs went off, and he was like, okay, but it's just the way you can explain it, where a lot of hack guys, they can't explain that. They just get lost in that power triangle, and they throw their hands up because they don't know how to answer it.
All right. How long does one of these boxes typically last?
We do manufacturing wise, a PowerLink, it's a 5-year warranty, but there's really no moving parts, so they'll last about 20 years.
Okay. So in curiosity, this is a very specific instance to address power factor correction, which in electricity is just a little corner of it. How did you get involved in this, and how long have you been doing this?
I've been doing it since I was in high school. Actually, I was working for an electrician that was both electrician and a AC guy. He was both mechanical and electrical. And back in the day when I lived in New York, we were changing out a lot of the coolers in the city, putting in newer equipment or walk-in coolers and stuff in delis and different supermarkets and stuff. And the services they have in those old buildings were like 100 amp with the screw-in fuse and all that. So we put that new equipment in, it would blow those fuses. So we would go in with capacitors and bring the power factor up to whatever we could, and it would drop a lot of the amps off of the system, which then we were able to operate on that 100 amp service coming in without changing it. But if something happened to the cap, then the circuit goes back to where it was. So, but it'll drop a lot of amps, and that's part of the cooling too. So if I was able to drop, say, 200 amps in a building, which is pretty normal, and they have, say, a 1,000 amp gear or 1,200 amp gear in there, and I'm able to drop 200 amps off, that's a lot of heat on those bus bars inside that. So you're talking, 20% of that, that I can drop off at 200 amps. Plus it gives, like, if they brought another machine in, and they're not at full capacity on that 1,200 amp gear, they could just add another machine, because I've dropped it 200 amps. So they could add another 100 amps easily to it, and not have to go drop ground transformers or build up the system. In a lot of places like Ryobi, Hitachi, these places here that are moving machines in all the time as they change parts or change gears for car parts or whatever, they move other machines in. Next thing you know, they're like, we don't have a big enough service. We got to go out and spend a couple $100,000 on a new service and transformers. And, it's a lot easier to put in capacitors to lower that. So.
How long have you had the patents, or what dates are those?
The one I received the patent on power factor correction in 2012 is patent pending, and I got the patent in 2014, utility patent. The other one on power factor circuitry, I got last year on that, because it's the way I wire the caps. I could have got it a long time ago, because I never really changed my wiring method. But then as I saw people being nosy, opening up the boxes and stuff, because of the harmonics, then I went and got that patent on that. That was about 15 months ago, a little over a year ago. And then the third one that I have, I just received about a month ago. And that one is on solar generator and different things, but hydro solar. So I kind of trying to make solar work 24 hours a day instead of just 8. So I received that, and now I'm going out and doing R&D and trying to get that moving. So, and that one there, I can build any size, so I can go from residential to megawatt. So it just depends how big the solar array is. But yeah, just upsize it. But yeah, so I hold 3 patents total, and I got a 4th one that I'm kind of waiting on Saudi Arabia.
All right. Well, Mike, we've covered a lot of ground. Is there anything further that we haven't covered that you would like to bring out? And we've covered a lot of ground, but there's still a lot.
Oh, there's
Is there anything that you'd like to close out with?
Well, just that, do your research as you look through power factor correction and the companies that you're dealing with. And there's other options out there besides what the power company says. Obviously, they're in business, they're not a government agent. I mean, they're in business to make money, so they're going to do the best they can to make as much as they can. And regardless of what we do, it's always going to be that back and forth where I don't do that, it doesn't work kind of thing. And I've got to the point where my company, and like I said, I've been doing this for a long time, and I had to deal with that when I first got into this business as far as selling it as a energy saver. So I started out 2007 as an energy saver, and I combated a lot of that stuff to where I ended up having lawsuits and stuff against different people by saying it doesn't work. And so as soon as I go, well, how does that not work? It has to work. I mean, why does the power company put them on their lines? I mean, if it don't work, So anyway, that's what I say. Do your research. Ask a lot of questions on how they do it. It's easy to test knowledge. There's a lot of stuff online you can look at as far as power factor. I suggest go to our website and and go from there.
All right. And what's that website?
It's safekw.net.
All right. All right. And we've had Mike Papini, CEO of Global Energy Solutions Group, on today. And Mike, would like to thank you for your time. And if anybody would like to contact you, how should they do that?
They can give me a call direct at 317-410-9927, or you can reach me by email at mike@safekw.net.
All right, perfect. Mike, appreciate your time today, and look to talking to you soon.
Right.
Thank you.
Thank you. Take care now, Dave.
All right.
Bye-bye.